The intensity at the maximum in Young's double slit experiment is I naught. Distance between the two slit is d is equal to 5 lambda. You see the diagram here. See, this is the d, this is the d, this is the distance between the two slit S1 and S2. And here the maximum intensity in Young double slit experiment is I naught. Okay. And where lambda is the wavelength of light used in the experiment, what will be the intensity in front of one of the slit on the screen placed at a distance d is equal to 10d. Whatever this capital D is there, this distance is 10 times of this distance d. Okay, distance between the two slits. Then we know here that some of the important major points are the path difference is given by whatever the path difference is there from here to here, the two different slit, that is S2 into P minus S1 into P. Then if I'm going to write this one in terms of the capital D, then this we can write it as under root of D square plus D square minus D. Then we get the value that is a d into 1 plus 1 by 2 d square divided by d square minus d. Then we can further simplify this one as d times 1 plus d square by 2d square minus 1, which is nothing but d square divided by 2d. Then delta x we can write it as d square divided by 2 times this capital D, that is we can write it as 10 times of d. 2d is equal to d by 20. Then this d is equal to 5 lambda divided by 20, which is nothing but lambda divided by 4. Then delta 5 is equal to 2 pi divided by lambda into lambda divided by 4, which is equal to pi by 2, where lambda will get cancelled to 1 times and 2 times, that is pi by 2. Thus the intensity at the desired point is I is equal to I naught cos square 5 divided by 2. 5 divided by 2, which is equal to I naught cos square pi by 4. Cos square pi by 4, which is nothing but I naught by 2. We can see this one in the option number D. Option D is the right answer.